In this video, we're going to talk about the language of hypothesis testing. Okay. So first, let's define what a hypothesis is. A hypothesis is a statement regarding a characteristic of one or more populations. In this chapter, we're going to look at hypotheses regarding a single population parameter, that is, the population proportion, P, for qualitative data, or the population mean, mu, for quantitative data. Hypothesis testing is a procedure based on sample evidence and probability used to test statements regarding a characteristic of one or more populations. So our steps in hypothesis testing is going to be number one, to make a statement regarding the nature of the population. Number two, collect evidence or sample data to test the statement. Number three, analyze the data to assess the plausibility of that statement. And we have to use caution here. If our population data is available, there is no need for inferential statistics. So let's define the null hypothesis and the alternative hypothesis. The null hypothesis, denoted H sub 0 or H naught is what we call it. The little zero is cut off by my highlighting there, but that's a zero. It's a statement to be tested. The null hypothesis is a statement of no change, no effect, or no difference, and is assumed true until evidence indicates otherwise. A good way to remember this is we're innocent until we're proven guilty. The alternative hypothesis, denoted H sub 1, is a statement that we are trying to find evidence to support. So typically with the alternative hypothesis, we're testing whether something is greater than, less than, or not equal to the proportion or the mean that we just decided in the null hypothesis. So there are three ways to set up the null and alternative hypotheses. The null hypothesis, again, is a statement of status quo or no difference, and it always contains a statement of equality. So for your notes, tell yourself for H naught, it's always an equal sign. So our parameter will be equal to some value. Now, instead of writing the word parameter, ultimately we will say P or mu there, and then we'll say have an equal to sign, and then we'll actually put the value that we're testing. Okay. Now, the alternative hypothesis is a statement we're trying to find evidence to support. So we're going to use the same value we just used in H naught, but now the sign will change. So H1 will always have the same setup, right? Parameter, some value, those are the same, but it's the equal sign that changes. If we have a not equal to, we call this a two-tailed test, and it has to do with shading in our normal curve. If I'm saying it's not equal to some value, that means I'm looking in either direction onto my two tails. If I'm saying my parameter is less than some value, then that is my left-tailed test. And then if I'm saying my parameter is greater than some value, I'm looking at my right-tailed test. So in this example, we want to determine the null and alternative hypotheses. We want to state whether the test will be two-tailed, left-tailed, or right-tailed. Pause the video and see if you can come up with the null and alternative hypotheses for these two different statements. Okay, so on part A, it says, in 2008, 62% of American adults regularly volunteered their time for charity work. A researcher believes that this percentage is different today. So on this one, we're going to be using that 62%. That is our value, some value. Our parameter in this case would be P, because we're talking about proportion, right? This is not a mean, it's a proportion. And so our first statement, H naught, will have P being equal to 0.62. So remember, we always assume H naught will be equal to. Then for H1, the alternative, we have to decide, is it going to be greater than, less than, or just not equal to? Well, according to the wording here, it just says it's different today. So in that case, we're just saying it's just not 62% or it's not equal to. So here's what the first one looks like. Okay, H naught, P equals 0.62. H1, P is not equal to 0.62. So we write both of those for that one example. Now let's go back and look at B. According to a study published in March 2006, the mean length of a phone call on a cellular telephone was 3.25 minutes. A researcher believes that the mean length of the call has increased since then. Okay, so on this one, our parameter is the mean, or mu. Our null hypothesis will always be equal to, so we have equal to the 3.25 minutes. And then the alternative hypothesis is still using mu and 3.25, but now instead of an equal to, we want to know if it's increased, so we would be looking at greater than. So here is our null hypothesis. Mu equals 3.25, and the alternative, mu is greater than 3.25, or a right tail test. In our next video, we'll be discussing the outcomes that we might see for hypothesis testing.